So, balancing redox reactions, the second method is using the half reaction. Now, this is going to be different whether it's an acidic or basic solution. So, for here, we're going to do a acidic example, and then I'll have a second video on basic solutions. Often there are spectator ions that are left out of the redox part of the reaction. If they say in acid or in base, there may also be like hydroxide or hydronium ions part of the equation. So it's best to use the half reaction method in this case, where you're going to break the oxidation and reduction reactions apart, balance them individually, and then put the reactions together. So here are the steps. Step 1, write the unbalanced ionic reaction. Then write the half reactions for oxidation and reduction. Balance the atoms being oxidized and reduced. So you may need to check the oxidation numbers if you can't do that by inspection. Balance oxygen by adding water to the other side of the equation. So you have half reactions. If there's oxygen only on one side, balance it by adding water. Then balance the hydrogen by adding H plus ions in acidic conditions. And then there's an extra step for basic conditions that I'll talk about in my other video. Then make sure that both charges are balanced by adding actual electrons, putting E minus into your equation to balance the charges. You could be trying to get the charge to 0 because it has a positive on one side, or you could be trying to get it to any negative number or positive number for that case, just by adding the negative electrons to each side. If it's necessary, multiply one or both of the half reactions by a factor that will mean that the electrons are balanced. So in one half reaction, if you're gaining 3 electrons and the other you're losing 4, you'd have to multiply the gain by 4 and the lose by 3 so that 12 electrons are being exchanged. Then add the half reactions together and cancel out any common terms to make sure that the remaining atoms are balanced. Here's an example. That was a lot. That was just going through the rules. Example under acidic conditions. So step 1 said write unbalanced ionic equation. This would be what was given. So it is not balanced, and then you're going to separate them into the two half reactions. You can do this knowing that sulfur will become sulfur dioxide and nitrate will become nitrogen monoxide. Sulfur and nitrogen monoxide would not be a half reaction because sulfur would not be changing into nitrogen. Then it says balance any atoms that are being oxidized or reduced. So there's one sulfur and one nitrogen on each side. You don't need to do anything for that step in this example. Step 4, balance oxygen using water. So we're going to add 2 oxygens to a reactant in our first half reaction so that you know where the oxygen is coming from to create the sulfur dioxide. You do the same thing and it's 2 again. The nitrate going to nitrogen monoxide will also produce 2 waters. Step 5 was balance hydrogen using H+. We are in acidic conditions, so we're just going to put H+. Know that H+ will then combine with another water to create hydronium because it wouldn't exist just as a proton in an aqueous solution. But we're going to write H+ for the purpose of just the redox reaction. In our first half reaction, we had 4 hydrogens on the product side to balance out the water, and then 4 on the reactant side to balance out the water again in our second half reaction. Now we need to look at the charges. So in step 6, we're going to add electrons. This is what's kind of different from the other balancing types of questions. Here you had 4 hydrogens combining a +4 on the product side, so we're going to add 4 electrons so that both sides have a net 0 charge. The nitrate in your second half reaction makes a -1 on the reactant side, so to get a net 0 charge in the reactants and products, only 3 electrons needed to be added to the reactants. All sides have 0. Note they do not have to be 0, it's just in this case both half reactions had both the reactants and products add up to 0. It says it just needs to be equal, so both sides could be +3 or -4 or whatever it may be. Step 7 said, make the electrons lost equal the electrons gained so that your oxidation and reduction are balanced. Lowest common multiple of 3 and 4 is 12. So we're going to multiply our first half reaction by 3 so that the sulfur produces sulfur dioxide 3 times, and the second half reaction by 4 so the nitrate produces nitrogen monoxide 4 times. Then, once that is done, you have the coefficients. So you multiply that 3 and it's all of the coefficients. These are both the half reactions in our final answer, and when you arrive at the end of this step, what you need to make sure you have happen is 12 electrons are being produced and 12 electrons are being used up. The electrons have to cancel out. In your final balanced equation, you will not have any electrons just alone. You need to account for them going to an element somehow. So when we add these two equations together, kind of like a Hess's law reaction from the third unit, anything that's common on both sides would cancel out, so the electrons would go away. Let's do that final step. Here you have the electrons canceling out. You had 6 waters as a reactant and 8 as a product, so 2 will remain a product. You had 12 hydrogens as a product and 16 as a reactant, so 4 will remain a reactant, and your final chemical equation will be 4 hydrogens plus 3 sulfur plus 4 nitrate gives 4 nitrogen monoxide plus 3 sulfur dioxide plus 2 water. So in this equation, it was under acidic conditions, so that 4H plus will exist. You weren't given any of the spectator ions in the question. That means you have to use this half reaction method. You could not use the oxidation state method if the water and the hydrogen were not given in the question, because you wouldn't know exactly where to put them. So I'm going to do a basic example in a separate video.